Welcome to our competency-based question series designed chapter-wise to enhance your conceptual learning and understanding. Question 4. There is a pair of concentric and coplanar conducting loops of radii R1 and R2 such that the radius of second coil is equal to 0.01 times the radius of first coil. To which of the following is the mutual inductance M for this pair directly proportional? So the scenario that is given to us, it is somewhat like this, that there are two coils of radius R1 and R2, and for the smaller coil, the radius is 0.01 times the radius of the larger coil. And we need to find the formula for the mutual inductance, and then we have to identify that it is proportional to which of the given options. So let's try to find it out. So we can find it out in this manner. So let's assume that I1 is the current that is flowing through the outer coil, and N1 are the number of turns in the outer coil. Similarly, the number of turns in the inner coil are N2. We need to find out the magnetic flux linked with the inner coil. Since we are giving the current in the outer coil, the field will be produced by the current in the outer coil, and those field lines will be passing through the inner coil. So we will be finding the total flux linked with the inner coil, and then we can calculate the mutual inductance. So magnetic field due to coil 1 at the center will be B1, and it will be mu naught I1 divided by 2 R1, where R1 is the radius of the larger coil. So this is the magnetic field, and this magnetic field, it will be coming out of the plane of this paper if they are placed in XY plane. And if you can see that it will be coming out, so a current is in anti-clockwise direction. Using the right hand thumb rule, the thumb will point in the upward direction. So that the direction of the magnetic field will be coming out from this inner coil. So all these field lines will be passing through it. So we can easily calculate it out. And since the number of turns in the outer coil are N1, we have to multiply this field with N1. So B1 has to be equal to mu naught N1 I1 divided by 2 R1. N1 are the number of turns. Now flux linked with coil 2. So that will be N2 into phi2. Sorry, that will be N2 into B1 A2. So this will be the flux linked with the total flux linked with the coil. N2 be the number of turns. B1 is the magnetic field that is passing through it, and A2 will be its area. So we can use this value of B1 in this equation. That will be N2 mu naught N1 I1 A2 divided by 2 R1. So just I have used the value of B1 obtained from equation number 1. So this is the total flux linked with the inner coil. And we also know that flux linked with the coil is mutual inductance times the current flowing in the primary coil. So this phi m, it is equal to mutual inductance times the current in the primary coil. So that will be M into I1. So I can write it as that is equal to M times I1. So this I1 gets cancelled out with this I1, and we are left with that capital M is equal to mu naught N1 N2, and in place of A2 I can write pi R2 square, because this is the area of the inner coil, this coil, divided by 2 R1. And it is given to us in the question that R2 it is equal to 0.01 times R1. So R2 it is equal to 10 to the power minus 2 times R1. So when we square it, it will be 10 to the power minus 4 times R1. So I can write it mu naught N1 N2 pi, and R2 will be 10 to the power minus 4 into R1 square, R2 square divided by 2 R1. And this R1 gets cancelled out with this 1 R1, and we are left with M is equal to mu naught N1 N2 pi multiplied by 10 to the power minus 4 divided by 2. So we can see that mu naught is a constant, N1 is constant, N2 is also constant, pi is constant in 10 to the power minus 4, and 2, they all are constant, and one R1 will also be there. No? So this M, it is directly proportional to R1. So when we have solved out the formula for the mutual inductance, it has come out that it is directly proportional to the radius of the outer coil, because R2 is given to us as 0.01 R1. So we can write that option D is correct. Thank you. Keep learning, keep practicing, keep excelling.